Hi, I often get requests for explanations about how my calculator works, and so I decided to do this video to make sure everybody understands what each field really is. You also have a manual here that you can actually find all those fields, the explanation, but I'll go through the fields anyway, just to make sure we all cover everything. So the first thing is we need to deal with the inputs. So the first field is the number of virtual machines that my VDI environment will support. So in this case, I will use 1024. Now, how many concurrent VMs out of those 1024s you will be running? So let's say you run 900 VMs. Now you select if you're using full clones or link clones. Link clones leverage the View Composer service that is installed in vCenter server. Full clones are the old full-size VMs, but the interesting thing here is that they are also Vim provisioned. I'm going to use the link clones because I believe most deployments today are actually utilizing link clones. Now, how many vCPUs your VMs will have, your virtual desktops? In my case, I'm going to just use one because it's the most common. And what's the average vCPU megahertz per virtual desktop? So here is the thing. You really need to understand what's the average utilization in terms of CPU your users will have. So 200 megahertz is I would say like a medium average. Probably let's use 300 here. Now you need a buffer on top of the 300. So if you want to add a 10% or 15%, you can choose here. So that means that all the calculations for the number of megahertz per core or per CPU will be based on this buffer here. So I'm going to add 10%. That's what normally add. And finally, what's the memory size for your virtual desktops? If we assume that we are running Windows 2007, probably most deployments will see 2048 megabytes or 2 gigabytes per VM. Now, the full size of the parent VM is the size for the VM decay that you have assigned for the VM. So if you assign a 40 gig disk for the virtual desktop, that should be in here. If you assign a 30 gig disk, that's what you should see here. But in my case, I have 40 gigs for the VM decay, where I guess the OS and the patches and my applications will sit. Now we also need the thin size of the parent VM, and we need that because the way we calculate the replica is based on the thin size of the parent VM. So the best way to find out this number is actually to deploy your guest OS, deploy your application, your patches, and then when you go in Windows, you see how much free space is available or how much is consumed in the NTFS layer or the NTFS file system. So in my case, I'm saying that I'm using 35 gig out of 40 gigs. What we're going to do here is I'm going to change. I will say that I'm using 20 gigs, which probably is most common for Windows 7 deployment. And because we are using link clones, we also need to set the refresh rate. What does that mean? It means that when the user log off, the VM will be refreshed. However, you have a few options on how you set up VM review. So the first option is log off on disconnect and then refresh. In this case, probably you would set to 10%. However, you might want to keep the status of a VM for longer, and you might decide that you want to log off at 20%. The interesting thing here is this actually will determine the size of the delta. So if I use 20%, you see my delta grow. So it would be 20% out of those 40 gigs or 25%. So in my case, I'm just going to use 10%. Now it also has the ability to select a persistent disk where user data is kept if you're not using some sort of roaming profiles, or if you're not using VMware Persona Management. I'm not going to zero out here. I'm not going to include that into my calculations here. Nor I'm going to include the disposable disk. The disposable disk is that temporary disk that is deleted every time the VM powered off, and it hosts the virtual machine or Windows temporary files like swap files and log files. I'm not going to use that now. Now, number of desktop pools is what you're going to configure in View. The limits, the supported number today is 1000 desktops per desktop pool. So that's why it's showing an error here. So what I'm really going to do, instead of changing to 2 here, I'm just going to change to 1000 number of VMs, and the error should go away, or otherwise I'll have to go with 2 desktop pools. Next, you define how many parent VMs you have. Because we only have one desktop pool, we only have one parent VM. But if you have multiple desktop pools, you could have a single parent VM or multiple parent VMs. So I'll keep it at 1. Number of virtual machines per data store. So the limits here are pretty clear from VMware when we're talking about block storage. So 64 is the supported number per data store. You probably can go up to 120 if you keep your eyes on the number of IOs being generated against the storage array. And if you have an array that it's enabled with vStorage Array APIs or VAI, you probably can use up to 140. In my case, I'm just gonna say that I have 100 VMs here per data store. I'm also able to define how many user data disks or persistent disks per data store. I have not selected any persistent disk, so it doesn't really matter here. I'm gonna just put 0. But that would be how many user data disks per data store you're going to host. And normally what we do, we dedicated a data store for the persistent disk. So if you're using select how many, I think the limit is around 100 anyway. Now you also need to define the snapshots per pool, and that is quite important here. For if you're using dedicated replica data stores, and we'll talk about that later, you can actually use a lot less storage than if you're not using dedicated replica data store. So if you have a desktop pool that is using multiple snapshots, so you have VMs running with different base snapshots from the same parent VM, you would have multiple snapshots per pool. So most of us, what we do, we only have one snapshot per pool. However, during the recompose process, VMware will create a secondary snapshot, and we only delete the first snapshot once all virtual desktops are fully recomposed and operational. So at that point in time, you have 2 snapshots. So I recommend for every single desktop pool to select 2 snapshots at least. Here you define what's going to happen to the desktops when they are not in use. You have the ability, you can leave them powered on, you can put them in suspended mode, or you can power off. Most deployments probably you leave them on. However, you have the ability to suspend. The interesting thing with suspension is that vSphere is going to create a file called .vmss containing the memory footprint of that VM, and that will add to the storage footprint required. And even when you bring the virtual desktop from the suspended mode to powered on mode, that VMSS file is not deleted. So it's only deleted when the VM is actually powered off. So be careful with that. Or you can just power it off. The drawback here is it would take a little while for the user to be able to log into the virtual desktop, especially if they are using persistent desktops. And also you generate a lot of IOs against the storage array, and we know that IOs are quite critical in a VDI environment. So most deployments, probably what you see is leave it on. You can actually leverage the vSphere DPM to actually move VMs across hosts and power down hosts if you want to. Next, you define the architecture of your host servers. So how many sockets and how many cores per socket. VMware recommends up to 16 VMs per core. That's actually what it supported. I like the number 12 VMs per core, and that's what you see here by default, because in a lean clone cluster, you can have up to 8 hosts. And if you have 12 VMs per core, what happens is when you lose one of your hosts, and now you're down to 7 hosts, now you're running 16 VMs per core, which is the limit supported. So it's kind of providing a automated HA to work around failures. Also, you have here the percentual hosts used memory. So how much of the memory host you want really to use. So as you can see here, you have the ability to use 100%, 90%, or 80%. The recommendation is to use probably 90% of the host memory, leaving 10% for something else. However, this setting here works integrated with the host shared memory. So if I say that I'm now having TPS enabled, transfer page sharing, this number will go up because you're saying that you're only using 90% of the host memory. So there's more memory that needs to be assigned to the host. Now, if you combine here saying 10%, the number will go down because it's a combination between host use memory and TPS. For now, I'll leave here just in 100. Now, I have published an article mentioning that with Windows 7, you actually can get more than 10%, and people have been working with 10% transfer page sharing because of Windows 7 ASLR, which is memory randomization feature for security purposes. And basically, you can actually set your 30% if your workload is quite similar. If your users use the VMs and the desktop in a similar manner. But I would recommend running a pilot to actually find out what is your transfer page sharing ratio. And also, you can set here the VM memory reservation. The VM memory reservation not only reserves memory from the host to the VMs, but it also reduces the storage footprint. So if you, as an example, set the VM memory reservation to 50%, you actually reducing the amount of vswap file by 50%, and the vswap file is equal to the amount of memory for each individual virtual desktop. So it's a good way to actually reduce storage footprint, but you also need to take care how you play with memory reservation to make sure that your host don't run into memory contention. I'm not going to be doing any memory reservation here. The hypervisor memory overhead, so 1 GB for ESXi 5 or 4.1 should be what normally you would be consuming, maybe a little bit more, maybe a little bit less, but that should be the average, and that is actually added to the total amount of memory required for the host memory. Now you define the version of vCenter, and if you want to provide HA for your host. So as you can see here, you have 10 hosts now. If you add the HA, let's see, 13 hosts now. So basically, based on the number of 8 hosts per cluster, it tries to make sure that you always have an additional host available in case of failure. You can play here, or you can actually play in number of VMs per core, like I mentioned, with 12 VMs per core, which automatically guarantees that in case of failure, you have 16 VMs per core over the remaining 7 hosts. Here, the vCenter VM limit, number of VMs that are to be supported. So the supported number is actually 2,000, but I've seen many deployments where 2,000 was too much and vCenter was struggling with memory and CPU. And this is basically due to the amount of number of processes and tasks running in a VDI environment, like power on, power off, and refresh operations. Yeah, so if you're not running VDI, vCenter 5 can support up to 10,000. So there's a big drop there. I would recommend staying at the 1500 VMs per vCenter. Now you also can define the VMware 5. There is a number of calculations behind it, how we treat display resolution and things depending on the version of VMware that you're running. I'm going to stick to VMware 5. Connection server AGA. So do you want to provide connection server high availability for your brokers or not? So in most cases, probably yes. In a production enterprise environments, as you can see here, number of connection servers needed. If you change here, no, now it changed to 1. So basically doubles the. This guy adds an additional connection server. Now we select if you're running PC over IP or RDP. My recommendation here is if you're running both, go with PC over IP selected, because in some cases, especially if you enable 3D, you require more memory and more CPU. And this is actually all added to what's called a VM memory overhead per VM. So this VM memory overhead is a combination of the amount of RAM for the VM, the amount of CPU, how many vCPUs, and the memory footprint. Okay, so there is a table from VMware, matrix from VMware. They kind of provide some guidelines. I was able to do some reverse engineering here to actually find out what exactly the numbers are, especially around display resolution with PC over IP in 3D. So you define the number, how many displays. As you can see, when you change here, it changes the VM memory overhead. But it also changes what's called the video swap. Okay, this is if you're using vSphere 5 and VMware 5 with hardware version 8, you have a new vSwap file, and this is what it will change here, the video swap file. Depending on the resolution, so if for example we go with 4 displays maximum resolution, and if you enable 3D here as an example, 428 megabytes, your video swap could go up to 361 megs per VM. So this is something else that needs to be accounted for when you're sizing your VDI infrastructure. In my case here, I'm not gonna use 3D, and I'm gonna run a single display. You see my video swap file is 49 megabytes, and my VM memory overhead has been produced 246 megabytes. So now you have the option to select if you're doing direct or tunneled connection. In VMware 5, this is not really applicable, but more in the older releases from a supportability standpoint. So direct is basically the ability to connect directly to the virtual desktop with the display protocol. While if you do tunnel, there's the ability to tunnel that through a security server or a connection server, and encapsulate it with SSL or HTTPS there. So it basically applies to the number of connections a connection server and a security server can actually host. And if you're doing a tunneled connection or a direct connection, you also need to set up how many external users, and basically this will play part on the number of security servers you need. So let's say you're gonna have 500 here. Now you need 1 security server. Of course, I wouldn't recommend just a single security server. Probably want to add a second one for high availability and put a load balancer in front of them. Now, if you need to decide if you use a dedicated replica data store, if you use a dedicated replica data store, all your replicas are gonna be for its desktop pool are going to be in the same data store. The problem here is that you might have a lot of IOs, especially read IOs going to that replica data store during boot storms and login storms, and you need to make sure that data store is backed by some sort of like fast drives, perhaps some solid state drives. I would recommend use that as well, because the replicas are created in only there, and if you select no, the replicas are created in every single data store in use by a desktop pool, so you'll be consuming more storage. You also define what you want to do with your VM swap files. Do you want to offload it to local storage or not? Some organizations do prefer to do that to save shared storage. The only implication here really is you will rely on local disks. So you need to make sure that they are redundant. If they're not redundant, make sure you have a replacement disks to put in there. And also operations like vMotion will be a little bit slower, but it still work. I'm not going to use low storage. And finally here you add how much storage overhead you want to add to the total storage calculated. I would recommend to add something between 10 and 20%. From IO's perspective, you need to define here the first thing, replica steady state IOPS. Is how many IOs is your replica delivering during steady state, during the workload production. You really need to run a pilot here, but if you don't have a pilot, you need to size. I have published some articles in the past that proves that the replica is barely used during steady state. So if you want to use one here, is fine. Number of concurrent boots, the maximum supported by VMreview is 8, and then you say how many IOs at peak time a virtual machine will generate. So basically that will define how many IOs during boot time for the replica. Here probably about 600 IOs, 700 IOs. That's what I've seen in production environments. That's what I would recommend to leave. Now you will define how many IOs your virtual desktops run during steady state. So what I'm going to do here, because I'm not using persistent desktops, I'm going to zero out here. So I'm not calculating this bit. I'm only going to calculate the IOs for the delta. So let's say my VM is consuming 25 IOs on average during steady state. I've seen IOPS all over the place, from anything from 10 to 200 IOs. It really depends. It comes down to what the users are doing, what type of applications you're running, how the application interacts with storage. I would recommend you to find that out during the pilot, and then you define what type of RAID you're going to use. I'm going to use RAID 5 here. Now, the delta percentual read IO is you need to find out that it also dependent upon how your applications in your guest OS are configured and how they work. Windows are natively write intensive, so it's very write intensive by nature, and it writes a lot more than reads. What we've seen out there is if you get to a scenario where it's 50-50, you have done an awesome job. Probably you get this with application virtualization, but basically you are offloading the IOs from inside the virtual desktops to somewhere else on the storage array. Most of the workloads that we see probably range from 20% reads, 80% writes, or 30% reads, 80% writes. I'm gonna say here that I've got 30% reads, so my write IO is 70%. I'm gonna update here. So I haven't provided all the inputs that I wanted to provide, and let's have a look at the results. So from a compute perspective, I need 10 hosts. This would be the megahertz per core that I need, but we know we can't really get 3.9 gigahertz per processor as today. So you have a few ways to deal with that. So the easiest way really is to reduce the number of VMs per core here. So if I reduce the number of VMs per core to 11, 3.6, I'm going to try 8 VMs per core. So with 8 VMs per core, consuming an average of 300 megahertz, I would need processors that can do about 2.6 gigahertz. I'm already adding a 10% overhead that we selected here, so I should be fine. But if you already have the hosts in place, you might want to configure that properly for your hosts. Now, this is the number of VMs per host that I will have, 64, and I will need 2 clusters. Probably you have 2 clusters here, one with 7 hosts and the other one with 8 hosts, something like that. So if you're not doing any memory overcommit, you need 144 gig. However, with the parameters that we have selected, which is 30% transparent page sharing, this is the total amount of gigabytes that you need in RAM for your hosts for those 64 VMs. From a architecture infrastructure perspective, you will need one vCenter server. Remember that this is a single point of failure, so if you're concerned about that, I would recommend looking into vCenter Hybrid, which is the solution supported today to provide high availability for vCenter. Also, you have 2 connection servers here, 1 security server, also the same thing about high availability. And now let's look on storage. So this is a breakdown per VM on how we are actually sizing and calculating the storage. So full clones, nothing, because you are using link clones. I have about 4 gig for Delta, which is the 10% refresh rate out of those 40 gigabytes. No persistent disk, no disposable disk, 100 megs for log, 2 gigs for vSwap file, which is the amount of memory size that we used, your video swap file, and each VM we will be using about 6.2 gigabytes, and total VM storage that you need is 6 terabytes. So now we would see here some additional numbers to reduce the total of VM storage if we had selected something like offload vSwap file to local storage, or reduce the vSwap file. So this would be reductions, or we would add if you're doing suspended VMs, because if you're doing suspended VMs, you need to calculate space for the VMSS file as I explained. From my overall storage capacity, you will need 6.69 terabytes. And based on the IOs that we defined, you need 28,192 front-end IOs. So front-end IOs are the number of IOs going from your host to the storage array. And from a back-end IO perspective, you will need 75,442, which are based on the front-end IOs plus the array types applied to it. So this is more for those storage specialists that we need to calculate the back-end storage. So yet another breakdown here. You see parent VM total usable capacity 40 gigs. If you had multiple parent VMs, that would grow. The replica is also 40 gigs. And this is the number of IOs that you need for the replicas. So here I would recommend to back by solid state drives, so you don't have to put a large number of drives behind it. Then you have here 6.6 terabytes total usable capacity for the link clones, disposable disks, log files, everything else. It's breaking down on 10 data stores, and it defines the number of data stores based on the data store size. And the data store size is based on the number of VMs that you define that will run per data store. So you define 100 VMs per data store. That's what you need to run 100 VMs per data store. So there you go. You have here how exactly to size your storage array and how you provide the LANs. Those are the front-end IOs that you need per LAN or per export if you're running NFS file, and number backend. And here is the total number of front-end and backend IOs. Here on persistent, you would see the same thing if we are running persistent disks. What I do normally is sometimes I need to calculate the number of user data that I need to add. So I use the persistent disk as user data. So if I'm doing 2 gigabytes of persistent disks, it's going to add here, and it's also going to allow me to say, as an example, I need two IOs on average. 2 IOs on average, and I need to define I'm gonna run 100 persistent disks per data store. So here we go. I would have, all right, so I need 2.5 terabytes of disk space for user profile, even if I'm not using persistent disks. Now, if you are using persistent disks, of course, then you need all the data stores and to know the data store size and the number of IOs required here. So there you go. That's a quick run through, but you can also print if you want to. I'm not going to open here, but you could just print and you get a nice PDF with the results, so you can take to your architects or to your customers. Anyway, that was a quick introduction of the VDI Calculator.